Okay, this presentation is going to talk about how to complete one-step mole conversions using the mole roadmap. Now, the mole is a counting unit, and it's also known as Avogadro's number. He is a scientist whose work led up to the concept involved with this number, and so we've named it after him. So just like 1 dozen is a counting unit, 1 dozen equals 12 things, and a gross is 144 things, 1 mole is 6.02 times 10 to the 23rd things. So again, it's also known as Avogadro's number. So 1 mole is 6.02 times 10 to the 23rd things. Now, the things that we're talking about in chemistry are known as representative particles. And a representative particle depends on what we're talking about. So for most elements, a representative particle is an atom. So 1 mole of copper is 6.02 times 10 to the 23rd atoms. And if we have an element that is either diatomic or polyatomic, like the ones listed here, those are molecules. 1 mole of oxygen, O2, is 6.02 times 10 to the 23rd molecules. And if it's a molecular compound, those units are molecules, and if it's an ionic compound, those units are formula units. Now, the good thing is that if you're doing problems using mole conversions and you see the word atom or molecules or formula units, you know that it's asking a question that involves representative particles. So in addition to 1 mole being 6.02 times 10 to the 23rd representative particles, 1 mole also equals other things. So 1 mole is equivalent to the molar mass of a substance, which is the formula mass from the periodic table, in grams. And if you have a mole of any gas at standard temperature and pressure, it will occupy a volume of 22.4 liters. On a side note, standard temperature and pressure, STP, stands for the atmospheric conditions at which the pressure is 1 atmosphere and the temperature is 0 degrees Celsius. So the tool that we're going to use here is called a mole roadmap. And in mole conversions, we are always going to be given something, and we're always going to be trying to solve for something. And using the mole roadmap, what we can do is whatever is given is where you start, and whatever you're trying to solve for is where you end up. For example, if you're given something in grams and you want to calculate moles, we're going to start on the roadmap at this mass parking lot, and we will follow this arrow to moles. And right here you see what is known as a conversion factor. A conversion factor is a unit equivalent to 1. So just like 1 divided by 1 is 1, and 5 divided by 5 is 1, 1 mole divided by 22.4 liters of gas at standard temperature and pressure is equal to 1. And I'm just going to erase these for a moment. There. So I will provide more detail for how to use the roadmap as we go along here. So one thing that you notice is that I have some units here in red. When we're talking about mass, our units are grams. When we're talking about representative particles, it can be atoms, molecules, or formula units. And if we're talking about volumes of gas at standard temperature and pressure, the units are liters. So here we will do a mass to mole conversion. And we have to start by writing down what we know. This is what's given. I will circle it. put a square around it. And I'm going to write down what I know. I have 205 grams of copper, Cu. And I am trying to solve 4 moles of copper. All right, so the first thing that we want to do is we want to write down the number and the unit at the beginning of the problem, and then give yourself some space. For today's calculations, we won't need much more space than what I've shown you how to do right here, but for others, we will need more when we learn about in the next lesson. And then we look at our roadmap. So we are given 205 grams of copper. So we're starting at the mass parking lot. And we want to find moles. So we're using this arrow right here. So what I do is I take this, I multiply it by a conversion factor in which I have 1 mole on the top, and it's 1 mole of copper, and on the bottom it says molar mass. Now the molar mass for copper on the periodic table is 63.55. So that is 63.55 grams. Again, this is the molar mass of copper from the periodic table. And I have this little Mario guy here to help with doing the math because I like this. All right, so I have what I call Mario's rules, and in my rules, Mario does this. So I'm going to see if I can grab Mario. I don't think I can grab Mario here. I have to stop the presentation. And here, I'll bring Mario here. So Mario travels, he starts here, dun, 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 dun. So he starts here, and then he jumps over to this platform, and then he jumps down. Every time Mario jumps onto the top of a platform, we multiply, and every time Mario jumps on the bottom, we divide. So in this, oh, I just made Mario really big. 205 times 1 divided by 63.5 equals. And we'll get our answer. And the answer happens to be 3.22 moles of copper. So in our calculator, we type 205 times 1 divided by 3.55 equals, and we'll get that answer. Now Mario is really smart. So he knows that if you put 1 in there, it's not going to do anything. So here, dun, 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 dun. So we have 205 times 1 divided by 63.55. Now let me do that again, and I'll show you what Mario does. He does the 1 in his head. So I'll whisper that. 205 times 1 divided by 63.55 equals 3.22 moles. So 205 divided by 63.55 equals 300 and... I'm not trying to make him big, I'm just trying to move him. I turned him around too, that was weird. Okay, so let's try another one. How many mole, a container has 38.2 moles of neon. How many liters is this? All right, so we look at what's given, moles, and that's where I'm starting. So this is my point A, and I'm going to liters. And liters is up here, so I have to follow this arrow. Now on this arrow, I have 1 mole of neon is 22.4 liters. Now one of the main things with unit conversions is that the denominator in the first conversion factor has to be the same as the unit that you start with, because the goal is unit cancellation. So if we go back to this one, I started with grams, and in the denominator of my first conversion factor, the unit is grams, and it leads to unit cancellation. So Super Mario, in this case, is going to start here. Dun, 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 dun. So in our calculator, we would do 38.2 times 22.4 divided by 1 equals, and it will give us 856 liters. I'll do another one involving representative particles. A container has 8.20 times 10 to the 24th atoms of iron, and we want to know how many moles this is. So we are starting in the atoms parking lot, the representative particles, and we're going to moles. All of the problems today involve just one step. Tomorrow, or in the next lesson, we will learn how to take 2 steps, which is really easy. I know that I need atoms down here because the denominator of my first conversion factor has to be the same as the unit in what's given. So I am going from representative particles to moles, and it looks like I have 1 mole of iron is 6.02 times 10 to the 23rd atoms. So in my calculator, I would type in 8.20 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd. And again, you can eliminate that times 1 because it's not going to change anything. Now, the advice that I have for you is when you do this in your calculator, to put that in parentheses. So I would put parentheses 8.20 times 10 to the 24th, end parentheses, divided by parentheses 6.02 times 10 to the 23rd, end parentheses, equals, and that will give you 13.6 moles. All right, and we will do one more. What is the mass of 2.35 moles? The shorthand for moles is MOL. We dropped an E. That really shortened things up, didn't it? Of water, H2O, and we want to know what the mass is how many grams. So we're starting with moles, going to grams, and it says that the bottom conversion factor is 1 mole on the bottom, and it's the molar mass of water. Now, hydrogen on the periodic table has a mass of 1.01, and there are 2 of them, so it's 2.02. Oxygen has a mass of 16.00. That shouldn't have been there. And there's only 1, which is that. So this is the molar mass of water. So we have 18.02 grams. And let us bring Mario back here. Mario's going to take this trip. So 2.35 times 18.02 divided by 1 equals, and that will give us 42.3 grams of water. So I went through these examples for you. You can watch them again. I don't know what I just did there. That's weird. Your assignment is going to do 4 problems. I will make that a number 4. I don't know how that happened. It's going to be to do 4 problems. You are going to take a picture of your work, and you can either submit the image to me or you can email me the image. Either way, it does not matter. So you do need to show all of your work, just like I've shown here on each of these problems. And that concludes my lesson for you today. If you have any questions or feel like you need some help, please email me, and I would be more than happy to help you. Thanks.